6.2. Apply properties of rational exponents. What's the simplest form of a radical mean? Well, if it's in simplest form, if the radicand has no perfect nth powers, and no radicals on the denominator. So the third root of 3 would be simplified because there's nothing that I can multiply by something by itself 3 times to get 3. So we'd leave it like that. But this is not simplified because I know I can simplify it down to 2. And then remember that this is not simplified because that 1/2 actually means the square root of 9. And you can't leave a square root on the bottom. So you would rationalize that and get the square root off, which is really simple for this one because it's just 1/3. Okay. Do you remember how to do it if it's a strange number? Like 1 over the square root of 8. We'd multiply top and bottom by the square root of 8 to get square root of 8 over 8. And then we'd pull out a perfect from the square root of 8 to say that is 4 times 2, so 2 times square root 2 over 8. Then I would reduce that 2/8 to be 1/4. So my final answer would be square root 2 over 4. And we learned how to do that before, so that should be familiar with that still. Okay, like radicals are two expressions with same index and radicand. So that means like 2 times square root 8 plus 3 times square root of 8. Those are like radicals, so we could add those together and say that's really 5 times the square root of 8. So properties of rational exponents. If we have the same base, we can add the exponents and put them together. And that doesn't, we can use that with whole numbers or with fractions. So these are the same thing that we learned back in lesson chapter 5. We're just using it with the fractions now. So number 1, 4 to the 1/2 times 4 to the 3/2. We're going to add 1/2 and 3/2. And that is 4/2. So that's really 4. And 4/2 is 2. So that would be 16. Okay. A to the m times n, we can multiply those together. So 5/2 times 2 would be 2 to the 10/2. Multiply the top and the bottoms of the fractions. And that would be 2 to the 5th, and that would be 32. If we have a number here, we can split it apart and then do the radical to both of them. So we can have 16 times 4 is 1/2 of the, or square root of 16 is 4. Square root of 4 is 2, so that equals 8. And then you know that the negative sign means flip it. So that's 1 over 25 to the 1/2, which would be 1 over 5. We know division means to subtract, so 5/2 minus 1/2 is 3 to the 4/2, or 2, which would be 9. And then 27 over 8 to the 1/3, we can pull that in and say that the cubic root of 27 is 3. Cubic root of 8 is 2. Okay, example 1. Use the properties of rational exponents to simplify the expression. So same base, we just need to add the exponents. So what's 1/2 and 3/4? Well, we need to change them to like denominators. So that's 9 to the 2/4 times 9 to the 3/4. So what's 2/4 plus 3/4? That would be 9 to the 5/4. And we would leave that there. Okay, because we can't take a 4th root of 9 because there's nothing times itself 4 times that equal 9, so we can't simplify that one down any further. Okay, on B, if I have a power, I multiply it in. So that is 7 to the 2/3 raised to the 3rd power times 5 to the 1/6 raised to the 3rd power. And that would be 7 to the 2nd times 5 to the 1/6 times 3 is 3/6, so 1/2. So that'd be 49 times 5 to the 1/2. Can't do anything with the 5 to the 1/2. Okay, on C, it's division, so we just subtract it. So 3 to the 5/6 minus 2/6 is 3 to the 3/6. And we can go ahead and reduce that to be 3 to the 1/2. And we have to leave it there. D, let's pull it in. Well, let's go ahead and subtract it out first. So that is 16 to the 2. No, we can't subtract it out because we don't have this right basis, same basis. So let's pull that 2/3 out then. So 16 over 4 to the 2/3. And all that raised to the 4th power. So that would be 16 over 4 is 4 to the 2/3 to the 4th power. And then we need to multiply that out to say 4 to the 8/3. Okay, properties of radicals. A times B to the nth, we can pull those apart and say that is the nth root of A times the nth root of B. That's helpful when one number can go ahead and be simplified out of there, and then it's a simpler problem. For this one, we can go ahead and divide, or take them out 2, not in there, but in here, and split them up that way. Okay, use these properties. So on A, we have them split up, but they're the same radical, so we can go ahead and multiply it back and then put it under the same radical. So that would be the 5th root of 27 times 9, which would be the 5th root of 243. If you put that in calculator as 243 to the 1/5 power, you'll get 3. Now, do we need a plus and minus there? No, because this is odd. Okay, with this, again, same radical, so I can go ahead and put it under the same radical sign. And 192 divided by 3 is 64. And the cubic root of 64 is 4. Okay, go ahead and do those checkpoints. Start the video again when you're done. Okay, example 3. Write them in simplest form. Factor out. So we would go ahead and factor 128 in a factor tree. And that is what? Let me go ahead and make this a little smaller so I can do it over here. 128, 2 to the 64, 2 to 32, or 2 times 32, and that is 2 times 16, it's 2 times 8, 2 times 4, and that's 2 times 2. So we need to take out in groups of 5. So how many groups of 5 do I have? 1, 2, 3, 4, 5. And then I still have 2 left over. So that would be a 2. And I still need to leave that 2 times 2, or 4, under the 5th root sign. Now, example 4. Simplify the expression. Okay. We have 2 times 12 to the 2/3 plus 7 times 12 to the 2/3. These are like radicals, so I can go ahead and add the 2 plus 7 together to get me 9, and then leave the 12 to the 2/3. And is there anything that we can do with that? Do we have any groups of 3 and 12? No, because 12 is 2 times 2 times 3. So that's as simplified as I can go. Okay, on B, I can go ahead and what can I do? That is let's break this one up into 16, the 4th root of 16 times the 4th root of 3, because I'm just breaking my 48 into 16 times 3. And why do I want to do that? Because I know that the 4th root of 16, I can say, is 2 times the 3rd root of 4, or 4th root of 3, sorry. And then I still have my 3 here to 4th root. So I can minus, let me go back up here. This is seeming awfully confusing, sorry. I still need to put this term in here. So minus the 4th root of 3. Okay. Now, I can factor out the Okay, sorry, I got a little confused there for a second, so I had to stop and think about it. Okay, what is the 4th root of 16? That's where they got the 2 from. So now we have 2 times the 4th root of 3 over here, and then minus 4 times square root of 3. And so I don't need to rewrite this one. because that is that, and this was this, and so we have everything now. Put my sign here. So 2 of these minus 1 of those would be just 1 of those. So we get as our final answer the 4th root of 3. And these, I do admit that these can be a little confusing. So the only way to know how to do these is do a whole bunch of them. And let's look at the checkpoints. So write the expression in simplest form. Remember, we can't leave that cubed root of 9 on the bottom. So go ahead and simplify or split them up and then multiply the cubic root of 9 again to get rid of the 9 on the bottom. Let me show you how to do it. So we'll have the 3rd root of 5 over the 3rd root of 9. We can't leave that 3rd root there, so we need to multiply it by the 3rd root of 9 again, and then one more time, because it takes 3 of those to make a number that I can pull out. And then I need to do top and bottom again up here. So that would leave me with, on the bottom, I just have my 9 left over. And then on the top, I would have the cubic root of 5 times 9 is 45. And times 9 again would be 45 times 9, 5, 36, 40, 405. Yeah. Which is kind of strange, but that's okay. And then go ahead and do your factor tree for 405. Pull a number out and then divide. Now, on 4, this one's a lot simpler. We have 6 of these and 2 of these, so how many of those do I have? Okay. Example 5. If you have variables in there, the variables work the same way as the numbers do. So let's simplify the number first. What's the 5th root of 32? Well, that's 2, isn't it? And then I need to take out the x's in groups of 5. So how many groups of 5 do I have? I have 3 of them, don't I? Okay, on B, we'll pull that 1/2 in, so that's taking the square root of everything. So that'd be 6 helm squared into the 5th. On C, take the cubic root of that, so that would be, how many A's can I take out in groups of 3? I could have 3 groups of 3. And on the bottom, how many groups of 3 do I have? I have 2 groups. Okay. And then on D, I have, let's see. Ooh, that one's kind of complicated. Let's go ahead and do that in class tomorrow, if you'll remind me. Okay. Write the variables in simplest form. So we need to get rid of the 4th radical on the bottom. And then how can I do that? Well, if I multiply it by a b squared, Do you see that I'll have a b to the 12th, and that's a perfect radical? So if I pull this apart a little bit farther and put b squared here, then I'd have the 4th root of a to the squared b squared on top, and then on bottom the 4th root of b to the 12th, and that would be just plain b to the 3rd on bottom. Now, did I do that right? The 4th root of b, oh, not 8th, that'd be b to the 4th root of b to the 8th is b squared, not 12. Don't multiply them together unless they're a power. So that's where I messed up. So this is squared on the bottom. So that's as far as I can go, because I can't do anything with the tops, because I don't have anything I could pull out. All right, example 7. Okay, back to an easy one. So if I have 10 of something, I get rid of 6 of something, then I really have 4 of that somethings. 5th root of y. And then on b, I have these are exactly the same expression, so if I have 3 of them and 4 of them, then I have 7 of them. Okay. Go ahead and do the checkpoints and bring these tomorrow.